On this 6.7 power stroke, P0088 may mean the high-pressure fuel system is seeing rail pressure higher than expected for the operating condition. The truck may feel down on power, may be in a derate condition, and may keep a warning message up until it has been driven after the repair. Broadly, this can point toward possible high-pressure fuel control, valve response, fuel quality or contamination, return side flow, or sensor feedback concerns. Do not jump straight to a part. Start calm, prove the path, and let the test separate command, pressure, and flow. Before opening the fuel system, relieve fuel pressure, keep ignition sources and personal electronics away from fuel work, be ready for spills, and clean fuel residue before the engine goes back into operation. Also, be careful around energized injector wiring because it can carry high voltage. If regeneration starts during testing, let it finish before continuing because it can bias the values you are watching. Start with the code check. If fuel injector circuit faults are present, take care of those first before using this fuel system path. When P0088 is the code you're chasing, the flow moves to the high-pressure fuel system test, but other fuel system or sensor-related codes can steer you through shared checks first. For rail pressure context, one related FRP check defines correct FRP with the ignition on and engine running as between 34.47 megapascal, 5,000 psi, and 48.26 megapascal, 7,000 psi. But keep that as context and do not let it replace the P0088 decision path. If the diagnostic route sends you through the shared preliminary checks, start with the front-end accessory drive components and driveline. Key on, look for extra engine loads or concerns that could skew the fuel system diagnosis. Next, start the engine and monitor the PCM VPWR PID. The decision is whether the voltage is less than 15 volts. An open VPWR circuit concern is indicated by a VPWR PID value greater than 15 volts while the engine is running. Then, check the low-pressure fuel system. Key on, monitor the FLP pressure PID, control the FP status PID, and command the FP PID to 46%. The fuel pump runs for 30 seconds, then shuts off at ignition on, engine off, and on some vehicles the FP PID may not turn the pump off, so cycle the ignition from on to off if you need to command the pump off. For F650, 750, and F-Series Super Duty, the FLP PID decision is greater than 482 kilopascal, 70 psi. For all others, the decision is greater than 379 kilopascal, 55 psi. After that, check fuel quality for contamination. If the fuel quality check shows a concern, fix that before moving deeper into pressure control testing. If the route continues into cylinder contribution checks, carry out the relative compression test first and confirm all cylinders pass. Then start the engine and monitor the cylinder balance PIDs from CYL-BAL1 through CYL-BAL8, looking for the fuel balance quantity values to be relatively in line with each other. If they are not in line, verify the PCM fuel injector correction factor codes against the injector label on the engine. If the codes match, reset the minimum fuel mass adaptation for all cylinders with the scan tool. Restart the engine and watch the cylinder balance PIDs again to see whether the suspect cylinder is contributing correctly. If needed, run the power balance test. If the power balance points to a suspect cylinder, carry out a cylinder compression test on that cylinder and repair any mechanical concern before blaming fuel pressure control. If the path moves to FRP sensor checks, key on and monitor the FRP pressure PID. The bias sensor decision is whether the PID value is between 0 kPa, 0 psi, and 6,894 kPa, 1,000 psi. If the next check is return side fuel pressure, turn the ignition off, wait 2 minutes, disconnect the fuel return line from cylinder number 8 fuel injector, and catch any fuel in a clear container. Then key on, control the FP status PID, command the FP PID to 46%, and look for a visible steady stream from the return line into the container. If your route lands on the FRP sensor functionality check, start the engine. Monitor FRP voltage, raise engine speed to 1,400 RPM, then command FRP DSD pressure up to 180 MPa, 26,106 psi, and watch FRP voltage. Then command it down to 40 MPa, 5,801 psi, and watch that voltage again. The voltage should increase and decrease with the commanded pressure changes. For the P0088 path, carry out the high-pressure fuel system test with the scan tool. If that test shows a concern, remove the fuel volume control valve solenoid and inspect it for damage and corrosion. Repair what is necessary, install a new fuel volume control valve solenoid, then perform the high-pressure side fuel system reset with the scan tool. After that, clear the PCM codes and repeat the self-test. If the high-pressure fuel system test does not show a concern, continue to the fuel pressure control valve operation check. For the fuel pressure control valve operation check, turn the ignition off. Disconnect the fuel return line at the back of the left-hand fuel rail, plug the return line with the proper return line plug, and connect a suitable hose to the fuel return rail fitting. Route that hose through the wheel well into a suitable container positioned lower than the rail fitting. With the ignition on, command the fuel volume control valve to its lowest duty cycle value. Then command the fuel pump to 46%. Now command the fuel pressure control valve to its lowest duty cycle value while watching fuel flow from the left-hand rail, and then command it to its highest duty cycle value while watching the same flow. The expected behavior is fuel flow at the lowest duty cycle command and no fuel flow at the highest duty cycle command. Be patient here. Only a small amount of fuel may come out, and it can take time for flow to begin and stop. If the valve is stuck closed, rail pressure can build and the engine may start. If the pressure control valve flow response is correct, move on and validate the volume control valve with the pressure control valve already proven. If the flow response is not correct, remove the fuel pressure control valve and inspect it for damage. If damage is present, install a new fuel rail assembly. If no damage is present, install a new fuel pressure control valve. Then perform the high-pressure side fuel system reset, clear the PCM codes, and repeat the self-test. If the route sends you to the fuel volume control valve operation check, turn the ignition off. Disconnect the fuel return line at the back of the left-hand fuel rail. Plug the line and route a suitable hose from the rail fitting through the wheel well into a suitable container lower than the rail fitting. Key on. Command the fuel pressure control valve to its lowest duty cycle value and command the fuel pump to 46%. Then command the fuel volume control valve to its lowest duty cycle value while watching fuel flow from the rail. Command it to its highest duty cycle value and watch for the flow to stop. If the flow behavior is correct in this branch, install a new fuel pressure control valve solenoid, perform the high-pressure side fuel system reset, clear the PCM codes, and repeat the self-test. If the flow behavior is not correct, remove the fuel volume control valve solenoid, inspect for damage and corrosion, repair what is necessary, install a new fuel volume control valve solenoid, perform the high-pressure side fuel system reset, clear the PCM codes, and repeat the self-test. With the pressure control valve operation validated, check the volume control valve again in the validated branch. Turn the ignition off, disconnect the fuel return line at the back of the left-hand fuel rail. Plug the return line and connect a suitable hose from the rail fitting into a suitable container. Turn the ignition on, command the fuel pressure control valve to its lowest duty cycle value, and command the fuel pump to 46%. Then command the fuel volume control valve to its lowest duty cycle value while watching fuel flow from the left-hand rail, and command it to its highest duty cycle value while watching for the flow to stop. The expected response is fuel flow at the lowest duty cycle command and no fuel flow at the highest duty cycle command. If the response is not correct, remove the fuel volume control valve solenoid and check it for damage and corrosion. If there is a concern, carry out the diesel fuel system contamination repair and flushing work. If no damage or corrosion is found, install a new fuel volume control valve solenoid. Then perform the high-pressure side fuel system reset, clear the PCM codes, and repeat the self-test. If the volume control valve response is correct and the next branch is not available, pause, recheck the earlier diagnostic path, and avoid guessing. If the path moves into the fuel pressure control valve and fuel volume control valve electrical checks, start by checking whether the related fuel metering and pressure control electrical code group is present, without turning this into a long code list. On this Super Duty path, the next step is to start the engine and monitor VPWR again. The decision is whether the voltage is less than 15 volts. Then, with the ignition off, disconnect the fuel volume control valve solenoid connector and the fuel pressure control valve solenoid connector. Turn the ignition on and measure voltage at C1073 pin 1 and C1138 pin 1. Those voltages should be greater than 10.5 volts, and a known good chassis ground is needed for an accurate measurement. Next, key off. Disconnect the PCME connector and check the FPCV and FVCV circuits for an opening by measuring between C1073 pin 2 and C1232E pin 43, and between C1138 pin 2 and C1232E pin 1. The resistances should be less than 3 ohms. Then check those circuits for a short to ground. The resistances should be greater than 10,000 ohms. After that, key on and check those same control circuits for a short to voltage by seeing whether any voltage is present. If the wiring checks pass, key off and measure the solenoid resistance at the components. The fuel pressure control valve solenoid and fuel volume control valve solenoid resistances should be between 2 to 6 ohms. Then check the solenoids for a short to ground. The resistances should be greater than 10,000 ohms. If those checks still leave the concern present, disconnect all PCM connectors. Inspect for pushed-out pins and corrosion, reconnect everything fully, and verify whether the concern is still there. Only after that connector check and a confirmed remaining concern does the path call for a new PCM. If the concern is gone, the system is operating correctly at that time and the issue may have been a loose or corroded connector. Keep verifications separate from the valve testing. After the directed repair and the high-pressure side reset, clear the PCM codes and repeat the self-test. If the vehicle was in derate, it may still show a warning message after the repair. Drive the vehicle until the message clears from the instrument panel message center. The takeaway on P0088 is simple. Confirm the code path. Prove the high-pressure system response. Then use controlled flow and electrical checks to separate pressure control from volume control instead of guessing at parts. For more diagnostic training, visit stepdiagnostics.com.